Okay, this last bit that we're going to look at for this chapter is calculating something called the dot product and the angle between two vectors. So once you get past a lot of the gibberish that the book gives you, the formulas in this section are pretty simple. So if I have V is A1, B1 in the coordinates, and W is A2, B2, then the dot product, V dot W, now notice it looks like multiplication, and there is multiplication involved, but that's not the only operation. V dot W is equal to the A's multiplied together plus the B's multiplied together, so you get one single value as your answer. So as an example, calculate V dot W. So I would have 3 times negative 4 plus 2 times 1. So you have negative 12 plus 2. You end up with a dot product value of 10. Second example, notice this one is a little different from what was written in your notes, but between negative 4 and 1, 2. So the dot product is 8 times 1 plus negative 4 times 2. End up with positive 8 times negative 8, and end up with a dot product of 0. Okay, put a star next to that one. Ones that two vectors that have a dot product of 0 will have a very specific property that we'll get to in just a minute. Okay, the last formula is the angle between two vectors. So if I have vectors u and v, or v and w, or whatever I have, the cosine of the angle, so this is what I'm looking for, and my answer is equal to the dot product in the numerator over the magnitude of each multiplied together, the product of the magnitudes. So first example, we have v and w. We calculated last time their magnitudes. So to set up the cosine formula, cosine of theta is equal to the dot product of 10, we got a minute ago, over root 13 times root 17. Okay, in the calculator, strongly recommend that you do the denominator first and then do 10 divided by that value. Okay, so I'm going to do root 13. Now in my operating system, notice I can tell that I'm still under the root, so I need to hit the right arrow key so that the root ends and hit times root 17. If you have the older operating system, you would have had an open parenthesis after that first root, close it, and then do times in the second root, so you don't end up having a root under a root. And 10 divided by that value. So now I have cosine of theta is equal to 0.67. And then just like before, if I want to find theta, I need to do second cos. But first I need to make sure that I am in degree mode. So radian for all the graphing, degree for all of the theta calculations. So second cos of 0.67, and of course you can take it out farther than that if you want. Okay, I end up with an angle of a little over 47 degrees, almost 48. So there's an angle of 47 degrees between those two vectors. What about the one that I said had a special property a minute ago? So I need to calculate, so the first vector, I'll call this one V, and this one W, just like before, 8 squared plus, negative 4 squared, which would give me, let's see, 64 and 16. Root 80, that could be simplified, but since I'm just going to plug it into a larger formula anyway, I'm not going to worry about it. For W, 1 squared is 2 squared. So you get root 5. So then I use those two in my formula. Cos theta equals the dot product of 0, calculated a minute ago, over root 80 root 5. Now 0 divided by anything is just 0, so it doesn't even really matter what the root 80 is, and second cosine of 0 should always give you 90 degrees. Okay, so notice anytime you have 0 in the numerator, you're going to end up with cos equals 0, and therefore get 90 degrees or perpendicular vectors. Okay, so know that whenever your dot product is 0, you end up with two perpendicular vectors. Okay, here is an example. I'd like you to pause the video for a minute and try this one on your own. You have u and v, so calculate the dot product, magnitudes, and then the angle between those two, and see if it seems reasonable based on what the angle actually physically looks like. Okay, when you're ready, check your answers with mine. So I found in these blue and green steps you can do in any order. So I found the magnitude of each of u and v first. Then I found u dot v, so the dot product, 2 times 4 plus -1 times 3. Plugged the dot product and then the two magnitudes into my cosine formula, and then did second cos to get about 63.3 degrees, which does in fact make sense based on the visual image of the graph. Okay, what I'd like you to do now, this is the end of the video, end of the notes, take a minute and look at these problems out of your textbook. I post the answer key on SchoolFusion. Sorry, I post the answer key on OneNote, and so you can check your work and make sure that you're comfortable with the dot product and angle between two vectors. And then you're going to move on to some review activities to get ready for the quest. We should have time at the beginning of next class to answer any and all questions, and you're welcome to email me if you have specific questions as to the format of the test or what you will or won't have. I'm planning on giving you any formulas that you would need, but if you want anything more specific, you're welcome to email me.